Okay, so it's telling me a line passes through these 2 points here, and then it says, does it pass through this point, right? So we could graph, right? Now, for you, it's better because you're on graph paper. I'm on a tablet, but if I graph -3, -2, and then I graph 2, 1, 1, 2, 1, right? And I draw this line. All right, now it says, does it pass through 5, 3? 1, 2, 3, 4, 5. 1, 2, 3. Now, it doesn't look like it does, but it looks close. So how could we definitively know whether it does or it doesn't? Okay, let's think about this. A line, by definition, is straight. There's no such thing as a curved line, right? So in geometry terms, anyway. So if a line is straight, that means the slope of the line is the same everywhere on the line. So I'm going to figure out the slope between these 2 points, right? And the way we do that is we use our slope formula, y2 minus y1 over x2 minus x1. So the slope, right? So this is, let me get rid of that. This is x1, y1, x2, y2. So y2 is 1 minus -2 over x2, which is 2 minus -3. So the slope comes out to be 1 minus -2, that's 1 plus 2, 3 over 2 minus -5, that's 2 plus 3, 3/5. Okay, now the slope is 3/5 between these 2 points. Now I'm going to take the slope between this point, C, and either one of these points. So I'm going to do it between B, which is 2, 1, and C, which is 5, 3. Now, if it goes through that point, then it's going to have the same slope, 3/5. So again, this is x1, y1, x2, y2, and the slope formula, y2 minus y1 over x2 minus x1. So the slope is 3 minus 1. x2 minus x1 is 5 minus 2. The slope is 2/3. Now, there is no way that on a single line the slope can be different through 2 points. So we have conclusively shown that the line does not pass. No, it does not. Right? Now on graph paper, you would have easily seen that the point didn't line up on the line. But since I'm on a tablet, I really had no great way of seeing that, so I had to do it algebraically.